Morning, everyone. Welcome back to Pine Hollow Auto Diagnostics. We're in Staten Island. This is day 3. Working on a 2016 Nissan Rogue that was involved in a front end collision. It was hit hard in the right front corner. The body shop fixed it up. They said they have to replace the alternator, the radiator, cooling fan, and now this cooling fan right here does not work. This one does. So we have to figure out what's going on, do a little research. Now for these new cars in the aftermarket, sometimes it's really hard to get information. So I had to go all the way back to 2013 to get a wiring diagram, and I really hope that this diagram is accurate for 2016, since that's the second generation Nissan Rogue. Now, the thing about Nissan diagrams is they don't give you wiring colors here. They just, give you relays and I guess connector numbers, but dang, this might be tough. And there's no information really on all data for something this new. So what we're going to do is just go by this diagram, and our intuition and common sense, and see if we can figure out at least which fan we're talking about. So cooling fan motor 1 or motor 2. I'm not sure which one's driver's side or passenger side. The way we can figure that out is, well, let's look at the diagram. There's battery, 40 amp fuse, and this fan right here has constant power on 2 of the wires. This motor, on the other hand, has 2 constant grounds. Interesting. So we can unplug the fan motors and just check for constant power and constant ground and see which one, at least determine which one's number 1 and number 2. And then the way that they're controlled, so this is the intelligent power distribution module, kind of like a Tipham and Chrysler's, with built-in relays that are not serviceable. There's 1, 3, 2, so 3 relays in there. Then it looks like we have 2 external relays, relay 4, relay 5, just to control 2 fans. I mean, can they make it any more complicated? Seriously. So the more relays you have, the harder it is to kind of decipher the logic. What's on when, for low speed, for high speed. We do have some bidirectional controls. The launch can talk to this vehicle. There are no trouble codes for the fans. So we kind of have to take it from scratch. So I'm going to get out my test light first, determine which fan is which, and see if we can make heads or tails out of this one. So under the IPDM, we do have bidirectional controls. We can try actuation tests. Oh, no, let's go back. Not AC clutch. We want dual fan. So dual fan, high mode. Turn up. This fan kicks on, that fan is dead. So low mode, slows it down and it's still spinning. That's interesting. So in low mode, nothing works. So let's get back out of here. Yeah, I'm gonna start from scratch, unplug these guys, and see what wires what. One thing that I want to do is warm up the car until the cooling fans kick on, and see if they kick on at low speed or high speed, because the bidirectional test, it says low or high, but that doesn't necessarily mean it's low or high. So I want the car to naturally turn on the fans. We could push the AC button, but I actually want the coolant temp sensor to activate the fans. Meanwhile, I have the wiring colors labeled. So for the left side fan we have 2 black wires and 2 pink wires, and for the right side fan we have 2 greens and 2 tans. So your guess is as good as mine which one's hot, which one's low. Get the test light out and start doing some checks once they kick on, and we'll see what the result of this is. Well, we're at 210 degrees. The fans still haven't kicked on. Nothing. Let's keep giving her the beans. Alright, finally we have high-speed operation of this fan. That one is not working. And our temperature went up to 213, and now it's dropping. 204, 203. And now our fan is off. Okay. So we know the ECM is commanding the fans on. That's good. Now let's go back to the wiring diagram and do a couple voltage checks. Okay, the vehicle is off. I got my high amp test light in the 4 amp setting connected to battery ground. So if we touch battery positive, nothing happens. Should. There you go. Good deal. So now I have this fan unplugged, and I want to check what the pink wires do and what the green wires do. So here's pink. Oh, that's a hot manifold. Let's see, are my leads too fat? Let me get some other adapters. Alright, we got an adapter from the AESWave kit. I'm going to stick you guys right here. Let's see what's the best way to do this. Here's a test light. Let's get that in the shot. You'll see that light up. If we find a power, here's our connector. No. No. No power, no power. Our test light still works. Let's put the test light to battery positive now. If we touch a ground, it should light up. So let's see. Nope. Nope. I think we just found our problem. Let's get to the other connector and make sure the other fan has a constant power or ground. So basically we just found that either this fuse is blown, we're missing a power feed, or we're missing a ground, but we don't know the wiring color, so we have to check the other fan. Okay, so on the other connector, we're still connected to battery positive. Make sure our test light still works. It does. So let's check these black wires. Nice, that's constant ground. So the black wires are constant ground, so that just showed us that that ground for that motor is good. So that's cooling fan motor 1, that's the driver's side. So for the passenger side, we're missing a power feed from this 40 amp fuse. It's labeled M. Alright guys, so in the power distribution diagram, this 40 amp fuse M that feeds the cooling fan motor 2, so that matches up to our diagram, lives way down here behind the headlight. There's a little fuse block right down there, and that's our 40 amp fuse right there. Boom. Let's see. Rad fan 40 amp. So I'm going to take that out and we'll do some we'll do a visual inspection on it and see if we have power at the fuse block. There it is, blown fuse. Not too surprising. I think if the whole assembly got smashed back and those power wires shorted to ground, blew the fuse like it was designed. So I'm gonna get a new one of these, pop it in, and everything should work. So just as a proof of concept, I don't have one of those special 40 amp fuses in stock, but I do have a regular 20 amp fuse through a jumper, through some more AES adapters, which are fantastic for this sort of testing. They just plug in right into your banana jacks. So now let's try the bidirectional control with the launch. Let's see here. So key on. Let's wake this guy up. So we're gonna go to IPDM. That's where the fans are controlled from. Okay. Actuation test. We want dual fan. We don't care about data. And let's see. High mode. Plug this guy in. Woohoo! We got fans. And our fuse is not blowing, that's good. We can measure the current ramp on there, or at least get a number. So you see low mode. Low mode, let's see if it actually, it does run them in low mode. Sweet. Let's go to high mode. Get our trusty amp clamp out. This thing for quick measurements, you can't beat a handheld amp clamp. 40 amp scale, 3.0, right around our jumper. We got 12.6 amps, beautiful. And low mode, got about 4 amps. Sweet. Alright. Well, that fixes this Nissan. I'm glad it was something simple like a blown fuse. But we still needed the wiring diagram and common sense to figure this one out. Even without wiring colors, you can do your basic checks and sometimes you get lucky. So that's it for this one. I'll see you guys on the next one. Bye-bye.